Think there's this universal inequality for planar graphs that states that the number of edges is smaller or equal to 3 times number of vertices minus 6. Of course, it's derived gradually. We're not providing the proof here, but let's illustrate it with, for example, K5. Well, K5 is known to be not planar. We can try to draw it and see the maximum number of edges we can draw in it, or we can just directly apply the formula to knowing its number of vertices and edges. So K5, well, first of all, the number of edges in K5 would be n times n minus 1 over 2, where n is the number of vertices, which would be 10. And the number of vertices in K5, well, it's inside the name, it's 5. So would it work out for this inequality? That says 10 is smaller than 50 minus 6, which is not true. So it wouldn't work out. And let's now also try to draw K5. So K5 is like this. We can also try to connect all vertices like this without anything crossing. The definition of a planar graph, that drawn in a plane, nothing crosses, none of the edges cross. Well, we can connect these two, but at this point, we kind of stop the way to connecting these two directly with an edge. And instead of just drawing, we could just check this in the first place as we did. So this was illustrated for K5, for example. There's this, once again, inequality for planar graphs that the number of edges is at most 3 times the number of vertices minus 6.